Okay, in the previous class, we were discussing about the integrals. So we'll continue with few more examples, a slightly different one. You're having cos x by 1 plus cos x. Cos x by 1 plus cos x. We need to find out the integral of this cos x by 1 plus cos x. The value of 1 plus cos in the numerator also. Therefore, what I'll try to do is add and subtracting 1, and I'm subtracting 1 whole divided by the denominator is 1 plus cos x times of dx. Now I'll try to group this one. I'll try to group this 1 plus cos x and divide that by 1 plus cos x. So if I try to rewrite, I'll be getting the integral as 1 plus cos of x divided by 1 plus cos of x into dx. Right, or dx you can write down that later, minus again 1 is being divided by 1 plus cos of x times of what? Times of dx. Or to further simplify this one, so that 1 plus cos x will cancel out. You're just left out with 1. So 1 time of dx, multiplying this 1 times of this dx will just give us dx itself. Again minus sign is there. Again apply the integral for the second term. It is integral of 1 by 1 plus cos of x into dx. I've just split these two terms and we have got two integrals. Now what has to be done is we need to actually simplify this one. So if you go for the formula that I have given to you, I have got this formula. If you can remember this formula that I have given to you in the previous class, we know this cos 2 theta will be 2 cos square theta minus of 1 equals to this 1 comes on this side, it becomes 1 plus cos 2 theta. Or 1 plus cos 2 theta is what? 2 square of theta. But here you can observe that in place of this 2 theta, what you're having x. So put, I'll try to rewrite in this 1 plus cos 2 theta. So what you're having 2 cos square of theta. So put the value of 2 theta equals to, because here I have to get it with theta value. So now if I try to replace it, it is 1 plus cos. So 2 theta, what I have taken as x is equals to, on the right hand side also I have to get in terms of x only. But what is theta value? Theta value is x by 2. What? 2 cos square x by 2. You try to remember this formula directly. So what I said, you have to replace 1 plus cos x as 2 cos square x by 2 into dx. Or further, if you try to simplify this one, since you have integrated, you can add the constant of integration. X as it is, you can take the 2 outside, is 1 by 1 by cos square. So 1 by cos will become secant. So it will be secant square of x by 2 times of dx plus the constant of integration c. But integration of this secant square of x by 2 cannot be done directly. Therefore, we will go for the substitution method. So put the value of x by 2 to be equals to t. Or x will be equals to, cross multiply the 2 on the other side is 2 times of t. All right, x will be 2 times of t. Now let us try to differentiate this one. If I differentiate, I'll be getting differentiation of this x will be dx is equals to 2 times of derivative of t will be dt. Now you can replace this dx over here as 2 times of dt. Therefore, we'll get integral I is equals to x as it is 1 by 2 integral of secant square x by 2 will be t, and dx is what? Dx is 2 times of dt plus the constant c. Is this step clear till here? Any questions so far? Yes, Amal, any questions so far?
No, sir, no, sir.
So however this 2 is constant, you can take the 2 outside. 2 is constant outside. You are left out with secant square of t into dt plus c. But we know that secant square of x dx is nothing but what? Is nothing but tan x plus c. Integration of secant square is tan x. Therefore, I can replace this further. I can cancel out this 2 and 2 also. If I try to rewrite, I'll be getting x minus, this is nothing but tan t, right? Secant square t will be tan t plus the constant c. But what is the value of t here? P value is x by 2. So it is x minus tan of x by 2 plus the constant c. So that will be the answer. X minus tan of x by 2 plus c will be the final answer.